Hey, Spencer. So I hear you're doing some really great research in additive manufacturing. Maybe you can tell us a little bit about additive manufacturing and what you're doing in that field.
Yeah, absolutely. So I lead a lot of the advanced expeditionary manufacturing or additive manufacturing. It's a subset of advanced. Here at NIWC, work a lot of events with the Marines and out in the field. We build and design our own 3D printers. We print a lot of parts in the field and go to a whole bunch of experimentation events with the Marines.
So you put this word expeditionary in additive manufacturing. Tell me about that.
Yeah, so that means we take our equipment out in the field and we'll 3D print replacement parts right at the point of need. Reverse engineer the parts with different programs of records like XFab or like the TACFab, and then we work with the maintenance battalions and logistics battalions to print a lot of different parts.
So I hear the term, whenever I hear additive manufacturing, I also hear 3D printing.
Yep.
Are those the same or is that different?
They're the same but different. So a lot of times we think about 3D printing as like your home 3D printer. There's two main technologies we'll think of. So they're called fused filament fabrication, and that's when you see that like spool of plastic going into the nozzle and it's moving it around and drawing that part.
Sure.
And then the other one that you'll see is called stereolithography, and that's when it has like this vat of resin, and it creates these like very detailed parts, but it's a huge mess. A lot of hazmat concerns with that technology.
So you probably don't use that one as much then.
No.
Yeah, right.
Yeah.
How'd you get into this field?
So it all started back in like 2012 when I was finishing my undergrad in mechanical engineering. And I mean, even before that, like grew up building with Legos. I love just like tinkering with things, being able to take things from my mind and just make it. And so started studying mechanical engineering, thinking I'd just be able to make something. And then you go to find out, if I want to make something, I need to get an injection mold to make a plastic part, which means you have to mill it, which means you have to do this thing. And it's like, And he kept going, and it was like thousands of dollars to be able to make one little small part. And it was the very next week, it was like this beacon of technology when I saw our first 3D printer on campus. And it's like, wait, I can just send this part to that machine, hit a button, and I have an end-use like plastic part I can like take out and like test with and prototype with. So it absolutely blew my mind. It was like, I have to be involved in that technology and like help develop it and just use it. It had to be a part of my life.
Yeah. So Spencer, mechanical engineering.
Yep.
Where did you go to school?
I went to school at San Diego State University right here.
All right.
Yep.
Very good.
Yep.
And how did you go from school to here, the Naval Information Warfare Center Pacific?
Yeah, absolutely. So back in school, actually, I was going through the entrepreneurship program at SDSU. So I've got a background in running startups. My startup was in like this action sports PPE back in the day. Didn't work out like most startups did.
That's big difference than 3D printing.
A little bit, yeah. And then I worked at Solar Turbines, and then I worked for industry for a little bit. And when the opportunity came up for me to, join at NIWC, I was just thrilled. Seeing like robotics, hearing about like the work that was done here at the center, I was like, I have to go after this opportunity. And I've loved every minute of it.
Yeah. And so about how long ago was that before you started here?
This was like from 2012, and then I started here full time back in 2019.
Okay.
So I've been here for about 5 years now.
Yeah. And when you started here, did you start working on additive manufacturing right away, or were you working on something else and transitioned into this?
Yeah. So I worked in autonomous technologies or robotics. So I worked in just building a lot of different robotic kits for the Marine Corps, and then we're doing work for like Office of Naval Research and like their portfolio of autonomous technologies. And on that project, I just leveraged AM day in, day out. If we needed to 3D print a part and throw it on like a big vehicle, I would use additive manufacturing to go and 3D print that part and have it the next day and put it on there. Yeah.
Yeah. So what additive manufacturing was your answer to every problem, right? Whatever problem there is, you're like, I have a solution. Let's additive manufacture.
Yeah, it is an answer to a lot of problems. The water jet that we have in like the machine shop was the other answer to a lot of different problems we had.
Okay.
We have a lot of other rapid prototyping tools. But yeah, it's a huge tool. It's great to be able to use.
And so when did you transition from being someone who worked on a project to somebody who's running a project now?
Yeah, that was back in, I would say like late 2020, 2021 was when I transitioned. I had the opportunity to go and like pitch this project concept to our internal like funding boards, or NICE as it's called. And it got picked up. And then, 3-4 years later, here we are. I've been leading this project. It's been growing. Our machines are known like worldwide or DoD wide across the Marine Corps. Gone on a number of experiments, field demonstrations, and it's been amazing.
Yeah, that's awesome. So you use this acronym NICE, Naval Innovative Science and Engineering, right? Which we all say it's very nice, right? It's
Yeah, it's
nice
very
when you get
nice.
some funding from that. Yeah,
Yeah.
because you had an idea. So what was your initial idea that you pitched to that board?
Yeah, so the initial idea was it came from a Marine that was going on deployment and he needed a robot. He wanted to be able to 3D print this robot and sustain it. He's like, hey, I'm going out in the field. I want to be able to customize it and like print my own parts because more than likely we're going to break it. What printer can I take with me? Like, what kind of robot can I build? Like, how do we build it? How do we sustain it? And there was like some answers, like bits and pieces, but there wasn't a firm answer to that. And so that's really what I pitched to the review board was like, hey, here's a machine we can build that they can take with them in the field, transport it to a location and then 3D print replacement parts for their robots in the field and like kind of customize them and build them as they need them.
So you had this idea, you made this pitch. Did they love it right away? Did they give you some flack? Like what went from that idea to like actually getting some money?
No, it was pretty well loved right away. Like there was definitely a lot of socializing that we had to go through across the center. From my primary, work is in robotics here at the center, and then it's like, okay, well, how does this tie into AM? And it's like, guys, I got this AM thing.
Yeah.
So we pitched it. We kind of grew the concept into like different portfolios. Like here's different vignettes. This technology is applicable, and it sort of grew from there. Engaged with a lot of different Marine Corps groups, and like the big pivot point for us was when we finally got in contact with like the logistics groups and maintenance groups down in Camp Pendleton or up in Camp Pendleton.
Okay. Down or up, depending where you are. Right?
Depending on where you are. Yeah.
Yeah, that's right. So this Marine that had the initial problem, like, has this Marine seen the results of what you've been doing, or
I
happened?
haven't
Yeah.
I haven't seen or heard of him since. But I'm hoping someday, somewhere, he's going to get this
He'll cross
technology.
paths
We'll
again.
cross paths again. Yeah.
Yeah, that's it.
Yeah.
What is in the time you've been working on this project? What is the coolest thing you'd say you've 3D printed?
Ooh, that's a hard one. Okay, well, I think one of my favorite 3D prints and like kind of demonstrations we've done was last year. We were working with this lieutenant colonel in the Marine Corps, and we had this concept for a Marine who had a broken arm in the field, right? And the idea was you could take out your phone and you can create like a 3D scan of your arm from your phone. And so we would 3D scan this Marine's arm, and we'd 3D print a custom medical cast while in flight.
Yeah.
And so we took one of our smaller printers that we built, put that on the Osprey, and that Osprey took off. It started the print, and by the time it landed, that had a fully custom medical cast that was better than the cast that they would currently use in wrap. They could actually like clean the wound, treat it. And that was hugely exciting from like the medical application, and just to see the excitement of like the medical battalion for the technology, that later blew my mind. Was like, they're like, this is amazing, like this can save lives, because a lot of times it would get an injury and they wouldn't be able to properly clean the wound, and so having this like custom cast, this can save lives. So that was probably one of my favorite parts.
So the cast was open so they could clean it? Is that the idea?
Yeah.
Interesting.
Yeah.
The Osprey, that's the V-22 tilt rotor aircraft, right?
Yep, the tilt rotor.
Yeah.
There's a lot of breweries that will have that on their cans. Yeah.
Were you on the aircraft when it was 3D printing that at that time, or were the Marines 3D printing that on the aircraft?
Marines were fully 3D printing on it. So the lieutenant colonel was actually the one who operated the printer. I had to train him. I was like, okay, here's how it goes. Like, you got to click this button, hit it. We hooked it up to a little like power pack, and then just started it. We had one smooth flight back, and then on the way back, he's like, just try to get the printer to fail. So they were apparently pulling all kinds of maneuvers. Nope.
50 Gs or barrel rolls?
So some barrel rolls. They did some backflips on there. Yeah.
Did they get it to fail?
Nope.
Oh, all right.
Yeah. We had a later event where we actually did something similar in kind of the militarized Humvee, or the modern version of it. And we were sitting there. The Marines were kind of sitting there. We were like fixing some equipment for this other event. And they're sitting there kind of bored. They're waiting. And we're like, we'll be ready soon. We'll be ready soon. And it was like, idly, I was like, hey, can you jump the Humvee?
Oh, yeah.
And they looked.
Marines are like, challenge accepted. Right?
Oh, yeah. They jumped it. We have video footage of it going airborne, and like the printer nearly lifting off like the seat. We had it strapped down.
Yeah.
Slammed back down. And then they came back just beaming. Like, we couldn't get it to fail. And I was like, yes.
That's awesome. That's awesome.
Yeah.
So these 3D printers, like, do the Marines have them? Are they using them? Are they still in the R&D phase? Like, where are you in that like development research arc?
Yeah, they're in the late stage of R&D right now. We're working to get it transitioned and get it into the hands of more Marines. We have like a dozen, maybe almost 24 of them out in the hands of Marines, and they've just been torture testing these machines. They have one that they've been using for over 2 years, and it's that machine, it's like still chugging along and it's in rough shape, but it's still working. Yeah.
Yeah. And so these machines, where do they come from? Do you buy them? Do you make them? Like, where do these machines come from?
Yeah, so this came, it was actually kind of interesting. It came back from my senior design project in college, was to design a 3D printer. And in the back of my mind, I was like,
back from 2012.
Back from 2012,
Yeah.
I wanted to do this. Right. I had an idea. I was like, I think I can build like a really great 3D printer back in college. So like had a senior design project to build a really inexpensive printer and had that experience. And I was like, for years, I was just carrying this nugget. And I was like, okay, let me see if I can pitch this. So when that came, it was taking everything that I learned as a user of the technology and like having casually tried to design one and started just applying that to it. So yeah, we're in the late stage of the R&D. We build them ourselves. So everything I design is something that I have to be able to make, or this is my own criteria, make it here in the lab with the tools I have or with tools the Marines have. And a huge thing that we push, or that I push, is making sure the equipment is easy to maintain. And that's our gold standard for what makes something rugged. The Marines will break everything you give to them. You know, that's the classic joke. I'm very proud of it that
they can't break yours.
Oh, they can break it. They've broken it.
Yeah.
They've definitely broken it. But the big thing is they've turned around and fixed it. And that for me is like what's really special. Like when I saw a Marine out in the field event, like, Spencer, the printer's broken. It was like 10 o'clock at night and we're like there really late. And it was like, can you fix it? They turned a couple screws and immediately like, hey, we found these like loose things and we got it working. It was like 5 minutes later. And it's like, okay, the design is working. We got the right idea.
Yeah. How do you teach them to fix it? Or do they just, it's that simple, they learn themselves?
We teach them like the fundamentals. We'll actually have Marines come down to our lab and have them build the machines. So we've had Marines like personally build the machine that they took with them for a field experiment. And that was extremely helpful and informative in them seeing like how they think, like which screws to use even, and where to use them. And from that, like they can generally just fix it themselves, like once they have that experience.
The machines that they're using, are they the ones they built themselves?
Yeah.
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 Do you think that like they treat them better that way because they know it's like their baby at that point?
Yeah. And that's one of the things that we looked into, or that I looked into, is like what's the human connection to technology and equipment? So often, like these warfighters, I mean, they get handed a piece of equipment and they're like, go use it. And that's kind of it. It's like, here's the documentation. It's kind of like, oh, that's cool. It's like this thing. And then it breaks and they're like, they don't care about it. It's like, they're kind of done with it. And so getting them in for like a week or so in our lab, like here's the equipment, here's why I think it's important, understanding their need, having this dialogue, there's much more of a connection with the equipment that they have and more of a reliance and a dependence that they'll have on it. And it becomes something that's important to them, where it's like, I know I can make these things, I know I can do my job, and I know how to fix this equipment. It's really empowering. When you see like Marines that are going on and they're empowered to repair their own equipment that they then use to repair other things, like it's creating the right space.
What are some other things the Marines are excited about additive manufacturing with this, other than just medical casts?
So one of the things that actually was amazing that we did recently, this was at RIMPAC, or Trident Warrior. It's the largest naval exercise, right, that happens every year. We're out in Hawaii, and we had two of our printers on the Somerset, an LPD, and the RO pump failed. There was this big pump, and they were going to have to send the ship back. And so we actually 3D printed. The Marines were able to reverse engineer the part, 3D print the test fit on our machine in about 8 hours, put it on, make sure the design worked. Then this was in collaboration with Naval Postgraduate School. They had a metal 3D printer, and they 3D printed the raw stock part, CNC machined it, and it was within a week. Installed the replacement part that didn't exist. There was no design for it, nothing, just a shattered piece of metal, and get the LPD working again.
Yeah, that's impressive. And so they used yours to build the initial prototype.
Yep.
Yeah. Did they have to do multiple prototypes, or did the first one they print?
The first one fit.
Yeah.
So the first one worked out.
And then they knew they could spend the extra time on the metal printer to get the right one.
Exactly. Yep.
Are they using it mostly for maintaining things that break, like building parts for broken things, or are they using it to build modern or new things?
Yeah, and that actually is a great question. So a lot of the day-to-day will have like replacement parts, but one of the things that I love about advanced manufacturing or additive manufacturing is the ability to iterate and make new things. So for us and for me, designing our machine to be very, very quick to produce new parts, because we can go through that iteration cycle. Like I was thinking about the light bulb analogy. Like how many light bulbs did Thomas Edison have to go through before we got one that worked?
Sure. I don't know the answer, but yeah.
I don't know either. I think it was like 100.
A
It was
lot.
a lot.
Yeah. Yeah.
And so we see that in innovation is there's like an evolution of an idea into a concept, into like a final product. And so we'll see them use our equipment to rapidly iterate on an idea and get it refined to a point. It's like, this is a significantly better product. I usually like to think it's at least 5 iterations of any idea before you have something that's truly usable.
Sure. Sure. So have you seen the Marines do some iteration? Like what, can you give an example of something they've iterated on?
Oh, let's see. Trying to think of some examples I can give. There are, there was a helmet mount actually. So they had an adapter for it was for a audio equipment.
Sure.
When they initially employed this new helmet, it didn't actually have the mounts for their current headphones or their current headsets that they were using.
Okay.
And so that was also during Trident Warrior. A Marine was able to design the new mount, 3D print it, and it went through about 5 iterations. They had a new product basically that was available to adapt something, a current piece of technology, to this new helmet standard that they hadn't accounted for in the design of that like product set.
Yeah. That's neat. So these printers so far, you've put them in planes, you put them in cars.
Yeah.
Trains yet?
Not trains. We put them on boats.
Boats. All right. So above the water.
Above the water. Some small ships. Yeah.
Uh-huh.
Yeah.
They plug in. They need power. Do they run on batteries?
Yeah.
Have you thought about batteries?
Yeah.
How expeditionary are you trying to make these things?
We've done batteries. We look at it from what they're currently being used on. So there's 2 programs of record. There's the XFAB and then the TACFAB. The XFAB is like a big roof, kind of like this 30-foot expandable container that is this like innovation lab space almost. The Marines can just dump it anywhere in the field and they can reverse engineer new parts or like make new parts. And then the TACFAB is one that they can bring with them. So we look at those environments and they'll typically have power. They'll have some sort of generator with them, typically like 110 voltage. And then we design it for like no more than like a 15 amp breaker. So the way we approached our printer design was like, let's just take what you would have at home and all the little problems that people would have with this technology and just engineer it to the nth degree and make it as easy to use as possible and kind of like ruggedized. So yeah, they'll just take it, unpack the machine in a lab space and start using it with like all the same hookups that you'd have just in a regular house.
Yeah. What the Marines that are using this, like what are their backgrounds? Are they mechanical engineers too, or
No, we'll get a lot of like high school graduates, some college graduates on like the officer side. What's really exciting is they'll see like a 20-year-old Marine, he'll come to me, he's like, hey, I've got this idea. And it's like, all right, cool. Like, here's your machine, like go do it. And just seeing them connect to the technology, see something that they had in their mind to solve a problem, iterate, over an afternoon and get that in their hands. It's just like, that's one of the things that just gets me so excited with the technology is seeing people use it to like take their ideas and bring it to life.
Yeah. So Spencer, it's probably just not you on this project, right? You probably have some other people that you work with. What are the types of people on your team? What's that? Who helps you with this? Not by name, but like what types of people do you have?
Yeah, so I have 2 computer scientists on my team that contribute. We have some other aspects of the project that they heavily help with. So they'll help with some like system design. We work on the software side of the machine and like these different robots that we'll build. We use our own equipment day in, day out. So we not only just like build this printer to hand to Marines, it's something that we use daily on the lab side. We'll build different like design packets, and we work on our own autonomous technologies as well.
Yeah. So where do you see this project going? Like 5 years from now, where do you see this all?
Yeah. So hopefully we're working to get our equipment out there and in the hands of Marines. The equipment, the printer is called Amos. Mm-hmm. And so we're working to get that in the hands of more Marines and get it scaled up. So that way we have it readily available across the Marine Corps and then hopefully the rest of the Joint Forces. That's the direction we see it going, that we can hopefully adjust the DoD's thought when it comes to supply and maintenance and resupply of parts. And that's the first step. And then really how we think about innovating and like building and manufacturing parts as we move forward. There's this buzzword of like, I think Industry 4.0, right?
Okay.
And we think about distributed manufacturing. So like with these new technologies, we can build anything, anywhere in the world instantly.
Right.
Yeah.
we don't need a big warehouse potentially anymore. What we do for the raw materials to 3D print, right?
Right. Just spools of material. It's just spools of plastic, or like you have spools of metal, and you can have any part with just a spool material anywhere in the world. And so I liken it to there's a Marine that calls it a teleportation device.
Okay.
I can take this part and I can teleport it anywhere in the world.
Yeah.
And within a few hours, I can have that new part.
Yeah. I'd love to talk a little bit about just like advanced manufacturing tech. So this is like maybe separate from your project.
Definitely.
Like in the world about like what excites you the most about the future of tech in this field?
Yeah. So in advanced manufacturing, I've seen new PCB manufacturing. That's really exciting because that was one of the pieces of the puzzle that we haven't seen solved yet. Because if you can buy like chips from DigiKey, and now I've been seeing like pick and place machines and like PCB etchers.
Oh yeah.
Because now you can actually build electronics in your home garage if you want
Very
to,
cool.
and then you can like 3D print the housing for it. And it's
Yeah.
like, we think about like our consumer products, like all of them have some bits of like plastic, and then the electronics that really bring it to life. So I'm excited to see how that innovates. Metal fabrication is becoming more accessible now for like metal AM. And when we call it advanced, we'll call it like additive then subtractive. So there's like that CNC part.
Sure. So additive is one where it builds up stuff, and subtractive is ones where you get a big piece of material and
you cut it down.
Yeah.
Yep. Yeah, and that's what we think of like today is like subtractive manufacturing. You take a block of material, you cut it down. And with additive, when we call it advanced manufacturing, it's bringing those together where you build up a big piece of material and then you cut that back down into like a really refined part. And so that's been innovating and growing. But I think that electronics piece is one that really excites me.
Yeah.
Seeing that grow.
I guess if you do that right today, you have your plastic printers, and you have your metal printers, and then you might have your circuit board printer, and somebody needs to put that all together, right?
Yep.
But maybe in the future, then there's something that like incorporates all those printers together.
Oh yeah.
To like make that all like a little factory in a box, right?
Exactly. Yeah. And we've already seen some like fun research projects from different universities where they'll take like a 3D printer and they call it tool changing, right? Just like a CNC machine will have like different tools for different types of like part cutting jobs. Like you might have a big bit and then like a small one where if you need to like cut a finer detail, it will like swap tools. And so there was this company that made a like tool changer on a 3D printer where they like, it would go and grab like a 3D printed tool head, then it would like dock that somewhere and grab like a cutting tool head, like do a cutting routine, and then like go grab the print tool head again.
Yeah.
And I'm excited by technology like that because, yeah, you can get a pick and place tool head. You could get like a CNC tool head. And you can just swap all these different tool heads out. And yeah, you have like a little factory in a box, conceivably.
Right. I'm going to, people always talk about artificial intelligence and how AI and ChatGPT and all those things just is like revolutionizing everything.
Yeah.
How do you see AI benefiting this field, if at all?
Actually hugely beneficial to this field. So what we're seeing with like 3D printing, right now it's a tool, right? So a lot of people, they'll think of it before, we think of it as like a home desktop 3D printer. Oh, it's going to be in every single home. And it was like a big push to the consumer side to get it everywhere. And now I think we've matured with like additive manufacturing where it's like more of a manufacturing tool. And where it means the most as a manufacturing tool is like someone who can design something and like produce a new design and now they use this tool to make it, right? Just like how you'd have like a saw, cut a piece of wood, screw these together and like build it up, now you have a house. Where AI comes in and like machine learning is you can start describing parts to the machine and we're seeing even like university projects and like some different hobbyists like taking an AI tool, inputting the text and then modeling that part based on the text. You know how the saying like, a picture is worth 1,000 words?
Sure.
Well, to an AI, 1,000 words is nothing.
Yes. Right.
So you can describe a lot of like three-dimensional geometries with just words.
Okay.
Yeah.
Interesting.
Yeah.
Interesting. Have you do you see that you just type in, hey, I need a replacement part to fix this flange on this reverse osmosis thing and design it and print it.
Totally.
See what I get, right?
Yeah. 100%. Like you could probably just take that part. And this gets into like, we do that with 3D scanning, but now we could probably just take a photograph of that part or a couple pictures.
Right.
And the machine is able to like, if it knows like the scale, it can just model that based off of that data.
Sure.
Yeah.
No, I think that's really cool because today, I mean, you probably got people like making a CAD draw. Like how do people today make the file that the 3D printer needs to print the thing? Like what does that process look like?
Yeah. So we'll use a CAD or computer-aided design software. So you'll make a sketch of that part, you'll add dimensions to it, extrude it. It's what's called parametric design. and you'll model that, add in the different dimensions. I mean, that's my whole field and specialty of mechanical engineering.
Sure.
So yeah, you'll just design a part by applying all those different dimensions, and that's how you get the model to go and print it, send it to a step file or an STL, have the slicer like slice that part, and then the machine takes that G code or that slice part, draws the lines, builds up the material.
Slicer, slice the part. Is it cutting it? Are there knives? What's slicing, Spencer?
It almost is cutting it, right? So with FFF 3D printing, or really any form of 3D printing, it's building.
FFF is
fused filament fabrication.
Ooh, all right.
Yeah, or it's also called like FDM, fused deposition modeling. I've got,
okay.
It's a swirl of acronyms in here.
Yeah.
But it will take apart, and so it will draw it line by line, just like how you draw like a two-dimensional sketch on a sheet of paper, and it will layer that up. And each sheet of paper has a thickness of say like 0.2 millimeters, and so it literally does slice the part, draw the part, and then build those layers up until you have a three-dimensional object.
Oh, interesting.
Yeah.
Interesting.
Yeah.
Yeah. How long does it take to do this typical process of draw a thing in CAD and do and I guess you could go like, Chris, it really ranges on things, but like, give me an example of something simple.
It does. Something simple, I've designed parts in 5 minutes.
Okay.
And like
an L bracket.
Like an L bracket or like a cylinder. I mean, this would take like 5 minutes to model.
Okay, sure. For people listening to the audio, that was a coaster.
Yes,
we have our cups on so we don't make noise when we put them down on the table on the microphones. Yes.
Yes, this coaster would take about 5 minutes to model, and then it would take about 15, 20 minutes to print.
Yeah. Okay.
So within 30 minutes, you could have something like that didn't exist before that now exists.
Sure.
Yeah.
But I could see for the more complicated ones, again, the pump or things like that, right? The value of being able to take the picture and say, even if I don't maybe have the part, I might say, I need something to wrap around this. Mm-hmm. It's like, today you can take a picture of something and use Google Lens on it, right? And it's like, that's the Taj Mahal. It's like, oh, like that's amazing.
Yeah.
Yeah.
I think on the Apple phone or like one of the phones, they have it where you can take a bunch of pictures of it and it will make a 3D model of it.
Yeah.
And then you can take that 3D model and then 3D print it.
Right.
So you could like 3D scan a statue and print that.
Yeah.
Even today. Yeah.
That's cool.
Yeah.
You mentioned at the beginning that a lot of this, you were applying solutions to autonomous vehicles. Mm-hmm. And do you see this being beneficial for like making new vehicles, repairing vehicles?
Hugely, yeah. Like especially as we like scale down robotics today, I think we'll look at like smaller systems. So there is kind of a cutoff on where AM is, I would say, relevant, or you got to look at other manufacturing methods, right? It's like a big vehicle, like you might not want to 3D print, say, a boat or something like that, because that's like very big parts, very long time to print. But anything that's about fits in a 12-inch by 12-inch area, like a cubic foot, that's perfect for 3D printing and perfect for advanced manufacturing. And so as we get like these smaller robotic systems, we'll see sometimes like they'll crash, they'll fall out of the sky,
Sure.
Arms will break, or like usually it's plastic parts that break.
Yes.
And yeah, having a 3D printer on hand to just boom, here's the replacement part. You don't have to wait for it to get shipped out. That's hugely beneficial.
Yeah, with my quadcopter, it comes with 4 propellers.
Yep.
And as soon as I break those 4 propellers, then I guess I got to buy a new one.
Yeah. Right. And there's already like 3D printed design propellers on like Thingiverse or Things, or like one of the websites that produces like 3D models. I think there's fun research even on that space, like the toroidal propellers, where I think there's some university that made one where this was a more quiet propeller design.
Oh, okay.
And this is what I really love about like advanced manufacturing, additive manufacturing, is you can see someone has an idea for like, I'm going to make a quieter prop for a drone. And then within a week, you'll see thousands of people like across the world now making this new prop design and testing it out. Whereas before, it would be like one university that would make it, and it would be a paper somewhere, and that would be that, unless someone picked it up to manufacture it. Now it's like an immediate like global community manufacturing these parts.
Because when somebody puts out the file, it's very easy to have a lot of other people print it and test it. Yeah. I think that's neat. That's sort of like the model of open source software versus closed source software, right?
100%.
Yeah. Do you want the encryption algorithm that you don't know what it is? Or do you want the one that a lot of people have seen it, a lot of people have tested it, and a lot of people can break it?
Yeah. And that's what I really love too about this technology, is there's like such a community nowadays. There's communities of like groups that make 3D printers and try to make the best 3D printer. There's like the Benchy speedboat race that people see. It's like, how fast can I 3D print this little calibration boat?
Yeah.
I think the fastest time someone got it like 2 minutes. The print quality was like pretty bad, but it was really cool seeing the innovation that people have now, and like these communities that normally geographically be very separated come together in this like digital space, but also like in a physical way with like additive manufacturing that we'd never really had before.
Yeah, that's cool. When you said the print quality was bad, what does that mean? What's a bad print quality of an additive manufactured thing?
Yeah, a bad print quality. We look at things like different dimensions, how clean are the walls on the print, overhang performance. So like how far of an angle off the base plate can I print before it like starts drooping on the material? Because you're building up these layers and you can't 3D print in air necessarily. Kind of can to some extent if your machine is set up right. And so we'll see it kind of like mushy. It will look more like a blob than it will like an actual like part or object that you're going to print.
Yeah. Have you run your machine on this particular time test?
Yes, I have.
How do you fare?
We're in the top like 100, I think, of machines globally.
And how many machines are there? Like 102 or
like thousands.
Oh, all right.
Yeah.
All right.
Yeah.
So top 10% or something like that at least, right? Yeah.
I think at some point, I'll want to release like a speedboat run and see what we can do.
Yeah, that's cool.
Yeah.
You ever done that with the Marines to be like, who can fix it the fastest or something like that? Do they like to compete that way? Yeah.
It's really funny. This was totally accidental. We have this slider on like the touchscreen for our printer, and it's like speed, and it's speed of 100%. And the first thing the Marines do is like once they've run our machine a couple times, they'll just take the speed slider and just crank it up to like 200 or 400%.
Oh yeah, they overclock it.
Yeah, they overclock it.
I don't want to wait. Come on, man.
Yeah, and we have this profile that I call Icarus because it's like, oh, maybe it'll work, maybe it won't. It's like the flying too close to the sun. Yeah, they'll just take that profile and just send it even further, and I'm like, what are you doing? I can make the Amos go 300%. Look.
The warp core is going to explode. Scotty, I can't run it any faster. Scotty's the one that usually says that, right?
Yeah. It's just like that. And then usually they'll get like a failed print and it's like, yeah. But then usually they won't. Then sometimes they won't. And like, this is amazing. Yeah, it's just really fun. Just seeing them like connect and play with it. It's just like that. It's so much fun.
Yeah, that's neat. No, I think that's the, same thing in gaming computers, right? There are always people who like, they want to overclock their computer. I mean, for me, I just want mine to work, really. But there are the people who be like, but if I can get 3 more frames per second on my Unreal game, then I'm like, I'm winning on Counter-Strike.
Yeah, I'm fully an overclocker on my computer.
Oh, all right. All right, very good.
Yeah, I always overclock everything.
Yeah, good. No, my last computer build at home, I like leaned into like, what's the fastest processor and all that stuff, and now the computer runs so hot. It's like anytime I'm playing like a game or a video render or this and that, like the heat that comes out of this thing.
Yeah, I don't run the heat at home, so when it gets cold, like I have my printer.
Your 3D printer.
I got my 3D printers and I got my computer, and I'll run my 3D printers and my gaming computer, and my whole room just super heats.
Yeah,
it's like, oh, this is great. Now it's like toasty warm in this one room.
Nice. So you 3D print at home. What do you like to 3D print in your spare time, Spencer?
I'll 3D print like some like different props from video games that I played. Like I grew up playing this game called Halo.
Sure, I know the game.
So up on my wall, I've got a 1-for-1 replica of like the Halo assault rifle that's back.
Oh yeah, cool.
Like a plant wrapped around it, and then I'll also 3D print like a lot of different organizers. There's this open source project called Gridfinity that I absolutely love.
Okay.
So is this like, I think it was like 1 1/4 inch like little grid squares, and fully open source. You could 3D print your own little like organizers and containers for different things. So all of my like garage like tools are organized using that system, and even our lab tools are organized using that system.
Yeah.
To give it like a nice practical thing. And then I'll play like, I'm a huge nerd, so I'll play like D&D. 3D print little like D&D tiles and like miniatures and things like that.
Yeah. That's super cool.
Yeah.
What would you have for advice for anybody who's listening to this who like wants to get into this space? They're in school maybe like you were, and they're like, it sounds really neat. What would you suggest to people in that?
Yeah, just find a 3D printer. Really, like most of them these days are pretty good. Most of them will have a huge community around them too, and a lot of your early hurdles that we had when like I was getting into the technology have been solved these days. And there's a huge open source community of support for the technology. So even if you get a machine that's like not very good, generally somebody has figured out a fix to make it better. And so if you are like someone that's creative and likes to solve problems, like just dive right in. You can get a machine for $60 or even a couple hundred. If you spend 600, you get one that's probably turnkey these days.
Okay.
Yeah.
Yeah. And I guess as people are tinkering with it, like software, printing parts, this and that, like what you mentioned you have computer science, you're a mechanical engineer. Like, what do you think is an educational background that people should pursue if they're interested in working in this area?
I think if you'd like to design your own parts, mechanical engineering is a great degree. Really, any engineering degree, computer science. We've seen a lot of computer scientists actually even design 3D printers. I think one of the biggest like open source 3D printer projects, just like how you have people building their own cars in their garage, there's this huge community of building printers, and it's like, yeah, even just a computer scientist degree, you can build one. Really, like the barrier, it's really becoming more like Legos. It's not that high, so I would say just you can dive in. Probably, yeah, computer scientists, computer engineering, really like any technical field.
Yeah,
you're ready to get in.
Yeah, that's awesome. What now that you're math in public, 13 years into like this idea from when you had it in 2012 to now, like what's been your favorite part about working in additive manufacturing?
Really the innovation, I think seeing the innovation, the excitement, I'll always go back to like we use it in our lab day to day. I've used it day to day, and by far my favorite part is when I see people that have problems and they have this technology available to them and they can just solve it, and like they have the maybe a week or so of training to be able to solve it and design a new part, and seeing the excitement level of like, I had this problem and I had this idea and I modeled it and it just worked, and it was like, that's what I absolutely love. It's just the time you can go from having an idea to having something.
Right.
Way back again when I started mechanical engineering, you couldn't just solve a problem. It's like I could think of a solution,
right, but
then I would have to wait like a month and spend a lot of money to actually make that solution a reality. Now you can just make it a reality within 30 minutes or an hour or an evening.
Yeah. Spencer, did you ever watch the MacGyver TV show or familiar with it?
I'm familiar with it. Yeah. Right.
The MacGyver reboot was pretty lame, but the original one,
Yeah.
But like, I feel like what you're talking about is that, MacGyver always had the tape and the bubble gum and this sort of stuff. But like now you can MacGyver solutions with much better parts.
100%.
Yeah.
Yeah. You can MacGyver something and then you can share that file online.
So other people can MacGyver it too.
Other people can MacGyver your solution.
Yeah.
And you have this whole MacGyvering the next thing.
Yeah.
And you just get these really cool like ideas in like the real world that we couldn't have before.
Yeah.
Yeah.
That's super awesome.
Yeah.
What would you say in the time you've been working in this field is the biggest challenge you've had to overcome, that you were just like, this isn't going to work, or you were the most frustrated about something?
Yeah, I think it's always, it's never the research or like the technology development. It's always the programmatics that's hard.
Yeah.
Honestly. So there's a lot of socializing. There's a lot of getting people excited and building that momentum behind an idea to be able to get after it. That's probably the hardest part of like, and that's really true for anything. That's true for government world. That's true for the startup world, I would say. Even like, I remember that in startup, having to pitch to people and get them like brought in on the idea.
Sure.
I think with really anything in life, it's like getting something like sold and getting that momentum built out is definitely the most difficult part.
Yeah. So you mentioned you were in a startup before here, right?
Yep.
I assume in that startup you were told no a lot, and not because your idea was bad, but because just that's startup, right? If any startup you have, your idea is bad at the beginning, right?
Yeah. And I will say here too at NIWC, it's a lot less of a no. It's more of a refinement stage. Is like the much better way to look at it.
Sure.
And that's like taking an initial idea, because the initial idea we had, it was like the bones of it were there.
Okay.
And, there was enough to iterate. But then where we are today with like our overall concept that we're working towards, it's so much more fleshed out. It's so much more refined. And it goes back to that iteration side. You're not really being told no, but you're being told like, okay, this is the right path. Maybe you need to tweak this or that.
Yeah.
In the startup world, it was always like fail fast and like, fail fast, fail a bunch of times and move on to the next thing. And like, this is a really like safe place to be able to fail and like iterate and ideate.
Yeah.
And it's like, it's a very empowering environment to work in.
That's awesome.
Yeah.
It's great to hear you say that. One of the things I often say is, I feel like here, great ideas, the first time it comes out of your mouth, you might not get money for it, right?
Yeah.
But if you continue to talk about it for a while, right? People will be like, the fact you're still passionate about it, right? Like, if you've listened to what other people have said, right? Like, it just gets better every time. And then all of a sudden, people start to like they start to nod their head and they start to pay attention. And they're like, we should do that. Why aren't we doing that? Yeah.
Yeah, there's definitely a lot of like, when you see people like, why aren't we doing this? You're like, okay, we've got it.
We're good. Yeah. So do you think having that experience from the startup was even though it might not have been successful, right? I guess we talk about failures, right? Like, was that valuable for you?
100%. Yeah, I learned a lot about like building a team, putting it together, refining a concept, pitching it. I like in NIWC when I first came in and I kind of learned about like the internal investments and like how like a lot of the like government research like projects really evolved. Is like, oh, this is like a government run incubator. That's the way like I like to think about it personally, is all like, this is like a government run incubator where you can have an idea, you can pitch it, you can get some funding, you can build a team around it, you create like a minimum viable product of like the idea, you start researching, and then you kind of grow from there, and you figure out where the transition is, and then you can move on to the next thing. So it's like this free space to be creative and solve like real world problems.
Yeah, that's neat. Speaking of transition and programs, like are people excited about Spencer's 3D printer, or
Oh yeah, there's so much excitement across, I would say, like programmatically across different Marine Corps groups. We have the Marines over at like First Maintenance are just using it day in, day out. We've had Marines over in Hawaii that are using it. It's almost a rivalry. We have Naval Postgraduate School has some of our machines, and then there's some on the East Coast. It's just the excitement for like our work and for our equipment and the technology we're developing at NIWC it's massive these days.
Yeah. That's awesome. All right. Well, Spencer, hey, I really appreciate your time on the podcast today. Thanks for being with us. We always use this phrase in Pacific. We're bringing the power of information to the fight, but you're really bringing the power of manufacturing to the fight.
Thank you so much.
Thanks, Spencer.
Thanks.